Hey team, how's it going? I'm Corey. Thanks for joining me today. I go by CoreyJA on the internet. You can find me at CoreyJA.com, CoreyJA on GitHub, Twitch, and YouTube. And today we're gonna do some Advent of Code. So Advent of Code is these programming puzzle challenges that come out one a day in December from the 1st to the 25th. And we are one day behind right now. I am on day 8, which was yesterday. But we're going to do day 8 today, and then maybe I'll do another stream later this evening with day 9 to get caught up, or that is the plan. But for now, let's jump right into day 8. So day 8 here is Haunted Wasteland. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left to right instructions, or left or right instructions, and the rest of the documents seem to describe some kind of network of labeled nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, two nodes stick out, AAA and ZZZ. You feel like AAA is where you are now, and you have to follow the left-right instructions until you reach ZZZ. This format describes each node in the network individually. For example, I think RL is going to be the right and left, and then we have our nodes. Starting with AAA, you need to look up the next element based on the next left-right instruction in your input. In this example, start with AAA and go right by choosing the right element of AAA, which is CCC. Then left means to choose left element of CCC. And then from CCC, you get to ZZZ. By following the left-right instructions, you reach ZZZ in 2 steps. Of course, you might not find ZZZ right away. If you run out of left and right instructions, repeat the whole sequence of instructions as necessary. So right, left really means right, left, right, left, right, left, right, left, right, left, right, left, and so on. For example, here is a situation which takes 6 steps to reach ZZ. Left, left, right. So you start with AA and you go left to get to BB, then you go left to get to AA, and then you go right to get to BB, and then you go left to get to AA. I think I might have messed up the cycle. We're going to trust that you reach ZZ after 6 steps here. Actually, no, let's do it. LLR. So first we go left, and then we go left again from B, and then we go right from A to get to B, and now we go left from B to get to A, left from B to get to A. Wait, it takes 6 steps. I feel like it takes a lot more than 6. Our first step goes to B. Our second step, which is left again, goes to A. Our third one, which is right from A, goes to B. Now we go left from B and get to A. We go left from A and get to B. Oh, and then we go right from B and get to Z. Okay, 6. We got it. So then, starting from AA, follow the left-right instructions. How many steps are required to reach ZZZ? To begin, get your puzzle input. Okay, so we have 2 samples here, actually, which is nifty. I like having 2 samples, so let's get started here. So we're going to make a cargo new binary like we've been doing. We're going to name it 8 and haunted something. Haunted Wasteland. I like that. Haunted, oops, that's okay. Wasteland. And Wasteland has an E in it? It does. Cool. And then we're going to name it Haunted Wasteland. The only reason we have to specify a name is because our directory name starts with a number, and cargo crates don't like starting with a number. Okay, so we have 8. Let's add it to our cargo workspace. Haunted Wasteland. We can now cd into 8. Cargo run and get the hello world by default. Perfect. Let's pull open our source here, and I think I pulled this onto my clipboard, so let's do sample1.input. Nope. Nope, that wasn't it either. It is on the clipboard, though. It's this RL one. Perfect. I don't, like, I can strip out the space, but let's do that to make it, all nice. Okay, and let's grab our other sample input while we are here. New. Well, that was interesting. That's not exactly what I wanted to do at all. We made a new main file, but I don't want it to be called that. Like sample2.input. And let's. File cannot be displayed. Yeah, just, oh, wow. I don't know what kind of file that was. That was interesting, though. Cool, but now we have these two sample inputs. Perfect. And let's think about how we want to, well, we can set up our part 1 function. But we're going to need to parse it really soon. So that'll be what we get to in about 10 seconds here. And we get a usize, yeah, because it's a count of things. A usize will work. Let's just write to do for the moment. Let sample, we actually have a sample 1 input this time. Sample 1 input. And it's just sample 1. Perfect. And then we have let sample 1 answer, sample 1 part 1 answer. And let's debug out our sample 1 part 1 answer. And then just to set it up, let's also do let sample 2 input, let sample 2 part 1 answer, and debug that sample 2 part 1 answer out as well. This is just going to panic on not yet implemented because we have our to-dos, but this gives us a place to get started. Okay, so let's see how we want to parse. I think I'm going to say that there's a map that's everything. We have some instructions, which are the left and right, and then we have like some nodes kind of thing. So let's start with that. So we have a struct called map, and this has some instructions, which I think is going to be a vec of, let's just parse it all the way to like enum. So we're going to make a direction enum. And it's going to be just left and right. That one's nice and easy. And then the format defines each node. So yeah, so let's make a node that has, I don't really know if we need to store the name. We can store that separately, but we could do the name, and then we need the left and the right from it. So let's make a struct for node. And so I like how Copilot is going to make these options of boxes if we wanted to make this like an actually circular structure. We're going to make this a little easier by just having things be named and references. So we're going to have something, we're going to name our nodes, and then each of them is going to have a left and a right string, and these are just going to be pointers to the name, basically. And then how we store these in a map is we're going to do a nodes is a hash map from string to node. And we'll import hash map from standard collection. Okay, so I think this is basically what we're going to want to parse into. We have our whole map. It contains the instructions, and then it contains each node, where each node, it contains a map of each node, where the key is the name, and the value is a node structure that knows both its name and its left and its right. I don't think our node really needs to know its name. I doubt we're going to use this, but I think it's easier. It makes sense to parse into it. So now let's just write some impulse. I always like to start off with just a parse function, especially at our top level. So it takes an input string and returns a self. We've been just unwrapping for all of our error handling in these advent of codes. There was one day that I brought in might to forward errors up, but we never actually ended up catching any of them, so it seemed like unwrapping's fine for these puzzles. We could always make them more robust later, but that's not really what we need to do. Okay, so I think what I want to do here is let's split on the empty line, just so that we can do that. I like doing that. Let split equals input dot split on an empty line. So that's new line, new line. And then we're going to leave it as an iterator for the moment, just because I think that's fine. So then let instructions equals split. So this is an iterator. Split, man, having trouble typing. Wow. There we go. Split.next.unwrap, because we know there's going to be a first thing. And then we can do let nodes is the next one. So we have two strings here. And actually, let's debug these out just so we can see them. Oh, and then let's add a to-do just so that it can compile so that we can run it. Split needs to be mutable so that we can pull the next things off of it for an iterator, which makes sense. We should... Oh, two things. Let's do them in order that the compiler will tell us. First, parse is just never called. So in part 1, let's parse our map. Oops. Now parse at least knows it's called. Oh, and these are strings, that's why. I thought I was going to have to make our structures debug, which we will later, to debug them out, but I forgot that they're strings right now, because we haven't actually parsed them all the way. Okay, perfect. That looks like what we want. Instructions is just right, left, and then nodes has all of our nodes there. So let's parse our directions. Oh, hey, Opus, how's it going? Thanks for stopping by. I also love that little waving chick emoji in chat. That's fun. How is your Saturday going so far, Opus? Are you working on some more of your Ruby project? I like that one. That one's fun. So let's parse our instructions more. So we're going to take our instructions string, and we want to go over all of the characters here. And yeah, something like that. We want a map for every character, and if we get an L character, let's do direction left. If we get a right character, we do direction right, and then we panic if we get something different. Opus says, doing well, about to start on it after I eat some food. That sounds awesome. Hopefully you have some good food as well. Always good to get some good food before you get started on some projects. I had a nice breakfast this morning as well. That was good. Okay, so now we have our instructions parsed, and now debug is mad at us because instructions does not implement debug. But let's fix that. Our direction just gets a derive for debug. Sure, you can implement partial equals, equals, and hash. I don't think we're going to need those, though, so let's just remove them, and we'll add them as we go. Partial equal and equals could be nice, so I can say left equals left, but I'm not actually sure if I'm going to want that. I did want something else, though. Oh, I want to make these clone and copy, because I want to be able to just copy these directions without thinking about it. So we're going to make them clone and copy. Take a break to read some Twitch chats here. Opus says, unfortunately, my main PC has to be RMA'd because the cooler broke, and I'm just hoping I can guilt trip them into giving me a full refund even after the refund period. Oof. Well, no fun to deal with that. Sorry to hear about that, but hopefully you can get them to give you a full refund. That would be nice. I think that, it feels definitely possible with it having issues and everything, so good luck there. I hope that works out. And then, so now I want to parse these nodes, which are this part, and each line is independent, which is great. So we're just going to go over each line here, and we're going to map, and we're going to just do, we're just going to call node parse, which doesn't exist yet, but we can write it. Yeah, something like that, Copilot. So node parse isn't a function yet, but we can make it. I was hoping Rust Analyzer was just going to do the creation for me, but it didn't feel like it. Okay, so node, it just wrote its own parse method, Copilot did. So we're going to split on white space. Yeah, kind of, but not exactly. I think we're going to want, this one might be the first point where I feel like a regex might be useful, but we've been going crateless for all of these. So I think we will continue to just not use regex and do some splits and stuff, which will be okay. It's not like pretty, but I think it'll work okay. It would be really nice if I could just do split white space and grab all of these, but that's not exactly how it's gonna go. So let's do name and connections. Yep. So we're gonna split on equals because it goes space equals. Yep. So we're gonna split on this. We don't need to collect it to a vec. We've done that a lot in these ones where we've collected it to a vec initially and then grabbed things out of the vec. But instead here, we're going to do it with iterators and not actually make all these arrays today. So name is the first thing. And then connections, we need to do some stuff here. So let connections equals getting the next thing there. Perfect. And then let's strip off the parentheses at the beginning and the end of it. So let connections, wow. It's like Copilot heard me, which I don't think it did, but that's pretty cool. Oh, so we're going to strip the prefix and strip the postfix for the different parentheses. These unwraps mean that we know that this is going to match, like there is this prefix and there is this suffix. Okay, so now we have those. So now we should just have like BB comma CC. So now we can do let connections equals split on a comma and a space, collect to a vec. And that is basically our left and right. So now, and actually we're going to, again, not collect it to a vec just because we don't need to. We'll be a little better with our iterators today. And then we can just do we can almost just do let left equals connections next and let right equals connections next. The only thing I had to do there was make our iterator mutable. But now we should be good to go. And now I can just do self name left right toString. These were all going to be just references to strings, but to make lifetime stuff easier, we're just going to make them owned to put in node. And now let me read what Opus has been saying in chat. Sounds a little mean to say it that way, but to be fair, I paid a very premium price for a less than premium product and experience. I wanted to avoid having to move with a desktop, but at this point, I clearly need a desktop to have a stable daily driver, so I'll have a nice pre-built coming later this week, hopefully, at worst the week after. Otherwise, though, feeling the happiest I felt in months. Oh, well, that's awesome, Opus. I'm glad you're feeling good, regardless of how the computer stuff is going. But I do understand wanting to have a nice, stable daily driver desktop. That's what I've been rocking for a while. A desktop I've been using as my main PC, and it's really nice to have one. I agree, and the stability is nice. That's actually why I moved away from building PCs. Well, it's been a while now, but that's one reason I moved away is because I just wanted something stable and didn't want to mess with all of the parts and stuff. So I've been happy that way. Hopefully you are as well. But honestly, just really glad you're feeling good, and that's always great. I'm glad to hear that. Let's see. I think we're pretty parsed here, so I think we can get going. Do we have our full map parsed out? Let's try to debug map. It's going to yell at us because nothing implements debug, but I think we can just add some derives. Derive debug, and derive a debug up on map as well. Cool. Well, that looks like we're doing good. I think I did see something a second ago, though, in our map parse. We'd parse the nodes and debug everything out, and then we just do a to-do instead of actually, like, constructing ourselves. Too many. There we go. Oh, yeah. So nodes here, I parsed to a vec, but that's not actually what we want to do here. We map it to a node and parse it. I like that. And then what if we do another map where we map our node to node.name.clone because we want another one as our key, and then name. And then what I want to try to collect to is a hash map of string and node. And I hope that it can do that. Looks like it can. Love it. Let's just add some borrows here so the debug works. And I think now we should at least see some debug out thing of one of our maps. Hey, look at that. That looks like our first map. We have the instructions left, right, and then all of these different nodes. Perfect. And Opus says, I'd build a PC if it wouldn't cost me more in time and frustration than the extra cost. And at least with a more boutique builder like Main Gear, I'll get a computer that's better than I can build myself. I built my first desktop. Took me 10 to 12 hours over 2 days and an ungodly amount of frustration due to the case I bought being horrible to build in. Yeah, I built before. It's been a while. It's been more than a couple years. And I think I built my first desktop too. I had laptops before, but the first desktop I had, I think I built as well. And I don't remember thinking that the actual like first time build was the stuff that was super painful. It was just the maintenance. And I guess you don't really lose that if you get a pre-built machine, but I feel like when I've bought pre-built machines, I haven't had to deal with that quite as much. There's some correlation going on there, I think. But I think you make a great point, right? Building a PC definitely costs more when you factor in things like time costs and stuff. It might seem cheaper at first, but then you factor in the time costs and everything, and it's not quite as cheap as it sounds. Okay, so we have this parsed, and I think this is actually gonna be pretty straightforward. All we need to do now is jump through the map, starting with AA, getting to ZZ, and count the number of times we have to like do the instructions. So I think it's really gonna be like let mutable count equals 0. Let mutable current node equals AAA dot toString. This is where we start. And then we just go while current node does not equal ZZZ, because that's our stopping one. We do some stuff. At the end here, we just return our count. So I'll make the compiler happy about returning the right thing. Variables in the condition are not mutated. Yeah, we don't do anything here, and that is what it's mad about. So let's say let next node, or actually let's get current node. Current node, this is really current node name. So let's name it as such. So let current node equals map.nodes.get, get the current one. We always think we're gonna have it. So let next node name equals, we're gonna map on, ooh, okay, here's a fun thing. What I actually forgot about is I might not want the while here. What I think I want to do is I want to use iterator methods on instructions to make it cycle, and go through it that way. So let's actually get rid of this. I want to do let direction, let dir equal map.instructions. No. While let dir, it's sum because it's going to be an iter. Wait, is that right? No. While let dir equals instructions dot cycle. Uh-oh, I really thought there was a cycle method. We'll have to mess with this in a second. Oh, there probably is a cycle method on iterator. So make an iter out of it. Yeah, okay. So this loop will never exit. Consider using a loop instead with a let inside. Okay, but that means I have to do this, but that's fine. Let mutable instruction iter equals cycling it. Yep. So then I can just do, we'll go back to this one. While current node name does not equal the end condition, ZZZ. Let current node equals this. Let current instruction is going to be pulling the next thing from our iterator. We get the current node from getting it out of the map based on our node name, and then matching. This is where we match on the current instruction. If we get a left, we say that we go from our current, we go left. If we get right, we go from our current node and go right. So then we just do current node name equals next node name and count +1. And then we just count that up. I think that's right. Oh, that's that debug I want. I'm gonna remove some extra debugs. Cool. I think we just run this. 2 and 6. 6. And I think this one was 2. Right? Because you go from right, you go to C, from C you go to Z. Yep. 2 and 6. Love it. I think that's all we need to do, so I will do my input in just a sec after I read some chats. Opus says, oh, I also got a 7'7" teddy bear, which is making me happy. A 7'7", so not that the 7 inches is the thing, but is it 7'7"? Because that's, even a 7-foot teddy bear is big, but those 7 inches feel like they're gonna be absurd. That's pretty awesome though. That is one big bear. Oh yeah, we want to do it with my input, so let's just let my input answer, and debug it out. Now let's go grab my input. Oops. My browser was being a little silly there. My input, put it in. Yay, my input now exists. We get 1,000, yeah, 12,643. Yeah. Wow. 231.14 centimeters. It was from a local company as well, so I got it with 1-day shipping, and it was only $200, which is remarkably cheap considering both the size and quality. Oh, that's awesome that it's from a local company too, especially in terms of one, getting it fast, and two, I imagine it's like you said, a little higher quality when you can get it locally. That's awesome though. Yeah, and that's like, not bad, especially if it's, something that's making you happy. I'd say that seems well worth it. And that is one big bear. I'm still pretty impressed by that. Okay, you ready for part 2, team? Part 2. The sandstorm is upon you and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound to the laws of spacetime? Only one way to find out. After examining the maps a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all of the paths at the same time until they all simultaneously end at nodes that end with Z. For example, if you have this map, here there are 2 starting nodes, 11A and 22A, because they both end with A. As you follow each left-right instruction, use that instruction to simultaneously move away from both nodes you're currently on. Repeat this process until all the nodes you're currently on end with Z. If only some of the nodes you're on end with Z, they act like any other node and you continue as normal. In this example, you would proceed as follows. So you're on 2 things at once. So from 11A and 22A, you go left for all of them. And you end up at 11B and 22B. You keep going until they all end in Z's. So if only one of them end with Z's, you just keep going. That's not that exciting. So in this example, you would end up entirely on nodes that end in Z after 6 steps. Simultaneously start with every node that ends with A. How many steps does it take before you're only on nodes that end with Z? Okay. This one doesn't sound too bad again, unless we get into an optimization problem where it just takes too long. But let's just try the naive answer and we will go from there. But first, let's do some chats. Opus says, I'm interested in how many of these can be completed by ChatGPT's big data thing where you can generate and actually run Python. Of course, that ruins the entire point of Advent of Code, but people want leaderboard positions on anything. Yeah, so I think that would be a fun experiment to try out. This year's Advent of Code does have this nice thing up top, or did somewhere, about how they don't want you to do that for the leaderboard especially. And it was definitely there before we started, and I don't know where that message went. But I would be interested to figure out how many can be solved that way. It almost has felt a little cheating when Copilot has written whole functions for me that basically solve some of these, but that's a little bit less than just feeding the input in and getting an answer out. Okay, so let's just get started here. I might just kind of do what we were doing before and just do all of the actual logic here in the part 2 function. Because we have the data structure that's parsed out, and I think it's base. I don't think it's different than before. The only thing that's different from before is our starting positions, and when we are done. So yeah, let's go with part 2 here. And actually, we have a new input, don't we? Yeah. So we have a sample 3 input, sample 3 dot input. Man, 3. There we go. Finally got that typed right. Perfect. Hopefully we never get to this XXX one, because that one seems like you're never gonna leave. So I hope we don't end up there. Okay, cool. So now we have our input. Let's let sample 3 input. Sample 3 input. Let sample 3 part 2 answer. Yeah, and then debug out the sample 3 part 2 answer. Perfect. So now we need to look at part 2 here. And I think what we want to do is just pull out the starting positions. So just trying to decide what we want to do for this. Let's just write it inline for the moment. I'm actually just going to delete all of this because we have it up in part 1 and it is going to be basically the same here, but I want to just write it again. Okay, so let mutable, we can just like starting positions. We'll make it mutable in a minute. Starting positions equals map dot nodes dot filter for ones where the name dot ends with an A. And then we want to collect these to a vec. Awesome. And let's actually just debug out the starting positions just for a sec to make sure we are doing our part 2 right. The starting positions are 11A and 22A. Perfect. Okay. So now we actually are going to copy a lot of this after I just said we wouldn't. Let's set everything up. So oh no, let's just return count. That is going to be the right thing. We don't need the to do. Cool. Okay. So we have our starting positions. Current node. Oh, these are actual nodes. So let's just then do .map to their name. I could have grabbed their name from the keys too, but it's fine. It shouldn't really matter. This is why I didn't think we were going to need the names in the struct. We could have used the keys, but it's okay. A current node names is going to be a vector now, and it's just starting positions.clone. Do I need to clone it? No, I'm probably never going to use starting positions again. I can just hand it off. Instructions iterator is that, and then the while here is while current node names dot iter dot all, and it's not that the equals z, it's that they while we don't have them all end with z. Once they all end in z, we can stop looping. Perfect. Okay, so we get the current instruction, and then for current node name in current node names iter mute. Yeah, so we're gonna do perfect. So the current node then trait borrow string. Wait, what? Current node name. What are you? You're a mutable string. The trait bound string borrow is not satisfied. Oh, it already is a reference. And I was trying to make it a reference of a reference, and then it being mutable just made everything a little unhappy there. So the next node name for each of these is just going left or right. And then we set it, because we're doing iter mute, so we can set the thing back using the asterisk, right? So we have a reference to a mutable string. We can use the asterisk to set the actual array value, basically, or the vec value, because we're in Rust. And then that's it. For each of these, we do the looping, and then we keep going and count the count. And that gives us 6 for this example, which is the right answer. Cool. That was maybe nice and easy. Let's see if that works for let my part 2 answer debug my part 2 answer. Nice. I was wondering if we were gonna have to do any optimization here. I guess since this didn't return immediately, what we should try is running in release mode. We'll give it maybe 30 seconds here, but if it's not doing it immediately, that does seem like we might need some optimizations or something here. Because And this one's actually an interesting one for optimizations because in previous ones, we haven't done it, but there was an easy optimization, which was just do things in parallel because things didn't depend on the last answer. This one, though, is very iterative, right? Each loop relies on things that happened in the last loop. And so it feels like it's a little bit harder just to parallelize like that. I guess I could like try to do each, because we have multiple starting points. I could do each different starting point in parallel and then see when they all match up, but that seems a little difficult as well. My other thought is figuring out where like loops happen and then doing math based on that. But that also seems a little difficult. And I don't know if and when the loops are gonna like happen. This does seem like it would give us the right answer, but maybe it's just gonna take too long. I wonder how many starting positions we're dealing with here. Like how many of these there are. Starting positions dot length. I just want to see how many there are. There's only 6 of them. Yeah, it definitely seems like this is just slow, right? And that I'm not doing something wrong. But for some of these Advent of Code challenges, they're like doing it the naive way is just going to take too long. And you really do need to find some optimization trick to kind of make it faster. And I think that's kind of what we're seeing here. But I wonder if these loop. And it feels like they might. In this example, right, if we start with 1, 1A, left, right, so we go to 1, 1B, and then 1, 1B goes to 1, 1Z. Oh, that one's just so quick. There's no loops because we just immediately get to the bottom. But if we look at like this part 1, this one, right, we do some looping. Like from A, we get to B. From B, we get back to A. Oh, but we aren't looping at the same cadence of the cycle, so it doesn't matter. So that's going to be hard, right? But it does have something to do with the cycles. It's surprising it's so slow, but I'm not super sure what's going on either. Yeah, I kind of think we're just doing this a ton, right? Like here, let's just, this is not going to be efficient, and I would never do this if I actually want it to finish. But what if we just debug out the current node names and we just see them keep cycling? Yeah. So it's just cycling through nodes. 1, 2, 3, 4, 5, 6. Yep. It is like, and PDB V, like I bet that is valid. If we look at PDB, PDB goes to, yeah, right. It goes to this one. So like, I think they're all valid. I think it's just that this just, oh wow, that's a much longer set of instructions that we're cycling over. That's interesting. And like, I can evaluate one cycle for each of these. I think it has something to do with the amount of times we do a cycle, but what if it doesn't end on a cycle? What if it's just a few of these? Because I was thinking I can calculate for any of these where one cycle takes you, right? So I could walk through all of the things and get like a one cycle gets you to this spot. But I don't really know if that helps me get farther than that. Because I don't really think that we have to get all the way through a cycle to get our answer. Like there's, in theory, right, we could get to something that ends in Z's after just doing a few instructions. Or we could cycle once and then go 2 in. Or we could cycle 3 times and go 8 in. Or really any of those. And you really do have to hop to each one in the middle. Like, so where are the ones that end in Z's? Like, can we go backwards? Not really easily. Let's actually find all the ones that end in Z's. PPZ, ZZZ. There's not like a ton of them, doesn't seem like. Hmm. This one's a little bit of a tricky one. Let's see if we can spend a few more minutes and come up with anything helpful. So for each starting point, I could find the indexes in the cycle where it will end in a Z, right? So for each node, I can count the indexes where it ends in a Z, and then I can find. So yeah, I think that'll work, right? Because let's look at this one. If we look at all of these, okay, let's make a scratch pad one. Yep. So like 1 1A then goes to 1 1B, which then goes to 1 1B. Then you go right, you get to 1 1Z. These are all capitals, but it doesn't matter. So this one's really easy, but I think it'll show us what we want to do. So then this is like our 0 index, our 1 index, and our 2 index. And then from 1 1B, we could do the same thing. Do I care about 1 1B? Maybe not. Because maybe I only care about the A's. In this example, I only care about the A's, right? 2 2A, you go left, you get to 2 2B. And then from 2 2B, you go right. Wait, 2 2A. Oh, is this one 6? Right? Yeah, it's 6. Okay, perfect. So it's from 2 2A, then you go to 2 2B, and then you go right from 2 2B, and you get 2 2C. 2 2C. And then from 2 2C, you go left, and you get to 2 2Z. Yeah, okay, perfect. That actually, that seems to be proving out what I wanted. So after one cycle, but then actually, where does this go? 1 1Z. So then do I have to do 1 1Z out as well? Because that's where that one ends after a cycle? 1 1Z. So we did left, then right. So now we need to do left again. That gets you to 1 1B. And then from 1 1B, you go right. 1 1B, you go right. You get to 1 1Z. But that doesn't have to be the case, right? Because like from 1 1Z. So in this example, I can find how many times it takes to get to 1 1Z from here, and I can find how many times it takes to get to 2 2Z from here, and then find the least common multiple of 2 and 3, which is 6, and that's the right answer. But that feels a little bit like a coincidence. Because this one doesn't, like, loop. Because 1 1Z then just happens to get you to 1 1Z again. Oh, but then 1 1Z is a looper. Now this loops, right? Because 1 1Z, by doing a cycle, gets you to 1 1Z. So that's definitely interesting. Yeah. So I think I could find the ones of these that cycle. One, like you know which ones are going to cycle just by going through one thing, right? Like 1 1A does not cycle because if you go through it 2 times, you get to 1 1Z. But 1 1Z does cycle because if you go through it 2 times, you get back to yourself. That's interesting. So I guess I can figure out which positions loop. We can look at that, right? That might be interesting. Let looping positions equals map.nodes iter. Yep. So So now I think I want to make some like helper methods maybe somewhere. Do I want to make helper methods? What do I want to do here? No. We can just go from the names here. Oops. So this is a name of a node, and an underscore. So like here, debug out our looping positions. But here we want to go, the looping logic here is a little more than that. It's let mutable current node name, that's fine. Let instructions iterator, yeah. While current node name dot ends with a z. Oh wait, no. While current node name does not equal name. But that's not right either. How do I want to figure this out? Seems like it's slicing it's so slow, but I'm not super sure what's going on either. Opa said, did it for fun. My Python solution was definitely more on the simple side. Did you do part 1 or part 2? Did you do part 2 in Python while I've just been thinking about how to do part 2? Because that would be super impressive, Opus. Because part 2's given me a little more problems here. Because I don't even know if finding the ones that loop in a cycle's that exciting. But maybe let's do it, and let's not have this cycle. So let's just do while current while direction equals map dot instructions. What? No. Let dir in map dot instructions dot iter. We don't want the cycle this time. Phew, there we go. Okay. Haha, 4. Man, I'm really having struggles with my syntax there, but that's better. That closes that. Oh, there we go. That closes that. There we go. Everything's closed. You did both? Oh my gosh. So your Python solution is working. So you must have found the trick that I didn't, or do I just have a bug? Don't give me the answer, Opus, but did you find the trick, or do I have a bug? This just doesn't need the borrow. I ran into that one already. Expected reference to a string found string. Oh, what if I just make this a 2-string? Yeah. I'd say you're definitely overcomplicating it. Okay. Well, thank you for that. That was definitely helpful. I do need to think about that then, though, because let me at least do this because I'm like kind of already there, but I don't think this is what I want to do. We want to find ones where the current node name equals the name we started with. And then this just needs some like, yep, okay. But I don't think this is going to be helpful. Looping positions is 0. Okay, well that was really not helpful. My solution was second number is about 9 magnitudes larger than the first in my case, very big. My solution was roughly 50 lines of Python for reference. Yeah, so I'm definitely overcomplicating it. You figured out the trick that I haven't yet. But that's okay. Also, looping positions giving me nothing feels a little bit like a bug. Oh, no, there are looping positions in the sample. There just aren't looping positions in mine. Okay, so looping probably is not related. Cool. That was a fun exploration, though. Hey, Nathaniel, how's it going? Thanks for stopping by. Opus says, I'm going to order food real quick and make a Rust implementation. Actually, I'm curious how much I can optimize it. Yeah, for sure. I'm just going to sit here and figure out where I'm making things really complicated that I don't need to be. You end up entirely on nodes that end in Z after 6 steps. Do I find out how many times? No, because I don't. The looping thing is throwing me. Kind of want chicken, but I also don't, so I'm having trouble actually choosing something. That is the life in our household, Opus. We're really bad at choosing things, especially food. Choosing what we want for food is probably like one of the hardest decisions, and it's so unfortunate that it happens like multiple times a day. Okay. Why am I making this more complicated than it needs to be? Let's actually just take a look at our input. I want to find something that ends in Z. Where's something that ends in Z? Okay. And this lets you get to things that don't end in Z. So I don't think I can just say, when does each thing end in Z, and then like do some math on it. Because like that was my thought with the looping. Nathaniel says that you were able to solve your part 2 is only like fractions of microseconds longer than your part 1. Yeah, so I'm doing something silly. Let me just look through my code to make sure that I don't just have a bug, right? Because that would just be unfortunate. But I think it's just that I'm overcomplicating it. We get an instruction each time we loop. We stop looping when all of the things end in Z. For all of the current node names, we just move them 1 by following the left-right move logic, and then we increase our count and we keep looping. Yeah, so that isn't wrong, I don't think. Opus says, I'd like a chicken sandwich from Popeyes, but they never remove the pickle, and I always tell them to. Maybe KFC is the great equalizer I want right now. Oh, there you go. Just switch to a different fried chicken place. That's unfortunate that they don't remove the pickle when you ask. I would never ask for that because I love pickles, but that is pretty fair. Maybe you should just eat pickles. I'm kind of with you there, Nathaniel. Pickles are great. Okay. My only thought is something about greatest common multiples, but I think I need to leave that because I don't think these loop around in any reasonable way. I truly wish I wasn't so picky. Yeah, it's hard, right? It's a hard thing for sure. Wow. And the second part was 9 magnitudes larger than the first. Yeah, so like I don't want to wait 9 magnitudes longer for this. That sounds absurd. So there's got to be a math trick. There's definitely a math trick. Let's just try the only thing I can think of, I guess. And if it doesn't work, it doesn't work. But maybe we'll learn something. Okay, so function part 2 try to takes an input string and returns a usize, just like everything has so far. And we want some of this code. Like I want our map and I want starting positions. Okay, so then I want let like 2 end counts to equal a hash map from string to usize. Yeah, so like for each starting position, I want to be able to save their end count. So then like for start in starting positions.iter, let current is start.clone count instructions while this doesn't end with while it doesn't end with a Z. You pull something off, you find the node, you find the next node, insert it into our end counts. You debug out our end counts. Actually, I don't even know if I want to debug out the end counts, but that's okay. So then like we do greatest common multiple. Do you think that's even something like, do you think, I wonder if Rust even has a greatest common multiple thing. Let counts equals to end counts dot values, collect it to a vec, because now I have a vec of usizes. They're actually references, but that doesn't really matter. I don't want the max. I want like the greatest or least common multiple. And I bet least common multiple, I bet there's not something like that in standard. Which is fair, but I kind of didn't want to but I didn't want to bring in a crate. Oh, that's the other one. I see. So there's probably a least common multiple trait that's on enter or something that they gave it. Yeah, it's this one. Oh, and that's not the implementation of it. That's just the okay. Let's just debug out the counts and do a to do. Let's just see what these look like. Oh, and that's not mutable. That's easy though. Mute. Oh, I'm not calling the right method. That was confusing. Part 2, try to. Part 2, isn't that what I called it? Part 2, oh, try to. Part 2, try to. Oh, is my part 2 named that? And then my part 2, try to is named that? That's confusing. Confusing, but I'm just not gonna do anything about it. Okay. Oh, well, of course that one worked for this one. Okay, so then I could like, oh, I can just do least common multiple kind of a silly way, right? Yeah, let's do it kind of the silly way, but I know what to do. Okay. Let counts, loop, so let, LCM count equals 0. Let mutable, while counts dot iter, while counts dot iter dot all. So this is gonna be C. No, not that at all. While they don't, just to do that right now, while counts at 0 equals C. So where counts is equal to counts at 0. Wrong direction. There we go. Okay, so while they don't equal it, you just keep increasing the L. Oh, so actually I want let counts and then let mutable current counts. That's not the best, but it's fine. Equals counts dot clone. So we do add 1 to this. We can start it at 1, increase it, and then we want to do for C in current counts dot iter mute. This equals, I actually do need an enumerate here. Actually, I don't need an enumerate. I could just zip it with counts.iter, the original counts. And now this is a tuple of 2 things, so it's this, comma, original, C equals original times the count. This, these actually I want to do cloned on so that they are less referencey. Okay. So then I want, so then I just want current counts at 0. And actually, let's see if that worked for the sample that I commented out. It's also taking a little longer than I would have expected, so that's not a good sign. Because I thought if this was going to work, it was going to work like immediately. Ooh, cool. I don't think my least common multiple thing is working. Because that should have been really easy to do. Okay, so let's just debug here my current counts so that I can see what's going on as we keep looping. And it just goes like crazy really, really quickly. Why does that go so crazy so quickly? Let's just actually blow up here for a second so that I can see my end counts. Yep. 2 and 3. Yeah. Wait a second. Unused variable current counts. Oh, because of the to-do. The to-do is what's saying, making it say that's unused. Okay. Counts. Debug current counts. Like, this should only take one loop, so it shouldn't even... Current counts was that, then we added it to 2, yeah. But then here, they should now be the same. Oh, I'm not doing this is not how least common multiple works. Not even a little bit. But Opus says, I got a bucket of chicken that I won't finish and some mashed potatoes. Heck it. Can always heat up the rest for tomorrow. Yeah, did you end up with KFC? That sounds great though. Okay, so for all of them, but now I want to filter it for where the current value I only want to increase the ones that are like, do I need to find the max here? Let current max, well, I can't do current max because that would mean that I would never increase some of them. But maybe the max is the only one I need to not increase. Yeah, I guess that's fair, right? There is only one that's the max that I need to care about here. Filter for C does not equal current max. Can't borrow as mutable because it's already borrowed as immutable for this. But we can just clone that so it's not. Can't compare. I think I want this on this side then. Can I compare that? Can't compare mutable mu size with u size. Partial equal is not implemented. But okay, can I do them in the opposite order or something then? Current max, it's not equal C. Just needed 2 of them. Got it. Try dereferencing it. Sure. Okay. That at least gets me to here. Oh, but I needed like the multiplier for each one now, because if I keep going, this isn't gonna do the, we're not gonna hit the right thing. Yeah. Oh, well, we actually hit 1818, but that's still not like the right answer here. So first of all, least common multiple is way harder than I wanted it to be, which is just silly, but not like crazy. But I don't even think, like, it feels like it has to be coincidence that it worked for the sample, because there's no reason it should work. Because, like, I don't know that they loop. Because I don't even know that the Z's loop. I know the C's loop in my sample because I looked at them, and they loop. 22C, yeah, So the Z's loop here, but they don't necessarily loop in the other example. Okay, chat. What are you thinking? I think I need a little bit of help. I want like minimal hints because I like solving these. They're fun, but least common multiple. Is that a good? Should I keep going down least common multiple, or is that not really the right answer? I feel like that's a hint that's not gonna give it away too much. Just gonna maybe stop me from going down the wrong direction for a while. Okay. LCM is right. Okay. Phew. Least common multiple is the right way to go. And maybe I just need to figure out how to implement least common multiple. I could pull in a crate, but I don't want to pull in a crate. We're gonna figure out how to implement least common multiple on our own. You will need least common multiple to solve this problem. Phew! Thank you, team. That is very helpful. So let's write a least common multiple method. And I think we're gonna do it on 2 of these because I think doing it on a list was giving me trouble. Least common multiple of 2 things. Whoa. Wait. That's oh my gosh, that is a much better way to calculate this than I was doing, Copilot. Oh my gosh. Well, thank you, Copilot. That was that answer. So how do you find the least common multiple? Instead of like doing all the multiplications that I was doing before, you just keep incrementing a number and checking if modding it is equal to 0. And I can do that for the whole array. Like least common multiple, like, yeah, let's just do it for the whole array. I can do that. That's easy. I just used greatest common denominator, GCD. I just use GCD, like something that is like from a standard library or something, because I don't think that's in Rust, right? Which is fine. I'm just like, I want to use the standard library just because I'm having fun. Let mutable least common multiplier is 1. It can just be LCM. That's fine. Just wrote your own function. Fair. I haven't written least common multiplier or greatest common denominator in a while, so it's fun to walk through them. And you use the nums crate LCM. Perfect. That is the math for LCM, and I would look at it, and I do already have an answer, so I don't think it's bad that you posted it, but I want to like not look at that for just a second. There we go. While we iterate through all the numbers, while they're not all divisible cleanly, we keep going and we do LCM. Okay, so now I have a least common multiple, and it's really not multiple, it's like multiplier. That's not how you spell multiplier. Spell multiplier. Multiplier. Oh yeah, there's no Y in that word. Cool. There we go. Okay. So let's take these 2 end counts. Okay, we have all of our counts. Perfect. Let LCM equals least common multiplier of counts. Debug out our LCM. And then like I just want to panic. And let's do the sample too, just to make sure my implementation works. LCM is 6. Wait, least common multiplier is 6. Oh yeah, that's what I wanted. I was thinking this isn't multiplier, and that's why I was confusing myself. This is the least common multiple because we actually get the high number that you multiply all of them by. I was thinking you got what I needed to multiply each number by, but that's not how LCM works because like the 2 is multiplied by 3 and the 3 is multiplied by 2. So I just was doing that a little wrong. Okay, so is the answer though just the LCM? Because it is for samples, for the sample one. So now we just have to see if we can get a least common multiple count for this thing. Least common multiple. Yeah, exactly. Thank you, Nathaniel. I wasn't reading chat at the moment, but it isn't the multiplier. It is the multiple. I was just trying to get my verbiage right. Okay, so still taking a while. That's not with release. So let's turn on release mode. Maybe there's just some magic Rust optimization. Not quite. And now let me read your implementation, Opus, to see if it was helpful. A divided by the greatest common denominator, A comma B times B. That's fair. How do you implement greatest common denominator then? Isn't that basically going to be the same thing? I guess I don't know how to implement GCD. Greatest common denominator, impl. Divisor, not denominator. Close enough. Least common multiple. Yep. See, so there's this that you basically while loop and mod. Yeah, but like that's not. Isn't that basically what I'm doing for LCM though? Is the while loop and mod? But I guess maybe greatest. Yeah, this is waiting for LCM to compute. Unless something else is happening and I didn't change the code like I thought I did. But I think I'm waiting for LCM to compute. Yeah, I definitely am. And let's just make sure that like it's doing something. Debug. No. Debug. Oh my gosh. Debug. There we go. I can type. So there's a really good chance that my LCM is implemented inefficiently, right? Because this is like not the best implementation of this, I have to imagine. But also, even with debugs on, we're getting to really big numbers. That's a really slow way to do this. Yeah, fair. What's a better way to do this? And I don't want to use the crate, right? So how can I implement LCM more efficiently? This is going to take weeks. Oh, no. Really? Oh, wow. Okay. That's fair. Ooh, love that answer. Let's ask ChatGPT. How do I implement least common multiplier efficiently? I could have just asked ChatGPT to do it, or not ChatGPT, but I probably could have just had Copilot do it too, which is maybe the easier answer. Function least common multiple. Yeah, it keeps wanting to do this for me. Impl this method. Okay, yeah, you don't copy the implementation I wrote that's bad. For result. Oh yeah, this implements it through GCD, but I don't have that. So I guess that wants me to implement it. Also, you usually only do 2 numbers, not a slice. Yeah, so the least common multiple with 2 numbers was easy, but then I wanted to do the least common multiple of all of them together, which I could have just done by like folding them or like reducing my array or something, but this seemed like the easier way to do it, but maybe that's just wrong. This thing says I should do it by GCD. Okay, so look, fine. Function GCD. No, I don't have this. Oh, wait. It's recursive. The greatest common divisor of A and B. If B equals 0, you just return A. Oh, interesting. I wasn't going to get there. That's an interesting implementation. That's right. That's a valid way to do it. Then just fold. I fold for the win. Okay. Yep. Okay, so we were at least on the same page about how to do the least common multiple in folding. But this is an interesting way to do it, right? This is well, actually, this one I'm not so sure about. The GCD that is recursive is really interesting. Greatest common divisor. Yeah, super interesting. Does this like work? Yeah, totally. Love it. Well, let's just see if this plugs in correctly, which I think it will. And then I want to look at these because I actually did kind of have a guess of what I was doing, but I didn't know the implementations of my least common multiple and greatest common denominator well, or divisor. Okay, but there we go. We got it. We did it. That's probably okay. It essentially folding via a loop. Yeah, exactly. This LCM does look essentially like it's doing the fold operation. Just a little more manually. Okay, so there we go. Got that. Day 8, part 2. What did I want to write here? The math was the hard part. And now just chatting with you all on chat team. Why is the least common multiple a valid solution to this problem, right? Like, how do we, is there something in the problem statement that lets us know that we can like loop, that like looping is valid? Did I miss a bit that like makes sure that's valid, or is that just like a, we just do it and it works, so we move on type thing? Until they all simultaneously. Yeah, and if you end on a Z, you just keep going. And no, there wasn't something specific in the problem that just told us this. We just kind of knew that we should do that. That's reasonable. A little unsatisfying though, to be honest. Because I don't feel like there's anything that says when you're on something that ends in Z and you go the same number of times it took you to get there. The data is massaged in a way to make it solvable this way. Yeah, that's frustrating. I'm not a fan of that, to be honest. I wish it was like spelled out a little bit more explicitly in the puzzle input, because then it just feels like that's a guess that that's solvable in that way. And I don't like that. You know, we got the puzzle solved, and I was on the right track. If it weren't, you would have to brute force this for years. Yeah, okay. At least we're on the same page, Nathaniel, because that's what I was doing. That's kind of where I was stuck, right? I couldn't figure out a reason that this had to work with the multiple approach. And I think the answer we're coming to is it doesn't. It just, the inputs will work that way, but there's nothing in the input that really points you to that. And I think that's what I don't like, right? I wish there was something here that pointed me towards that. And I know it works in the sample, but the sample is, the sample actually does loop. It's just interesting. I'm not a huge fan of it, but that's okay. Nathaniel says a real person would look at each A map to unique Z. There's equal numbers of each. Then the Z to Z number loops. The Z to Z number, does the Z to Z number loop? Because I definitely does in the sample. When I tried to look for things that loop in my input, I got an empty array. So I wasn't even finding a Z that thought it looped. But maybe they just loop on different cadences than I was checking. And that could be the case too. Oh, and my loop checks were actually different, because when I was checking for loops, I was checking for one round of the instructions, right? So here, a loop after two things, but that's not the cycle of these loops. They loop for however many times it took you to get to them, basically. So that makes sense. if you know all the z to z numbers loop at some cadence, that makes sense. That makes it pretty solvable here. You could also try CRT with this, but the numbers aren't coprime, so that won't work. Ooh, what's CRT in this context? CRT coprime. That allows CRT to work. Chinese remainder theorem. Oh, that's fun. I'm not sure I know about that one. Basically, the CRT says that there is a one-to-one correspondence between numbers in that set and pairs A and B such that the greatest common denominator of them equals 1, and A is less than N, and B is less than N. Oh, I think I've heard of this before, but I'm struggling to internalize it right now. There was a problem in 2020, I think, that was solved by CRTs. That makes sense. That sounds reasonably familiar a little bit. I wonder if this is one of the ones I struggled with because I didn't know about CRT, you know what I mean? CRTs wasn't in my headspace or vocabulary at the time. That's super interesting though. I'll at least remember CRTs in general for some later ones maybe. Here, what did this do for me? Okay, yeah. So everyone says to efficiently do LCM, you have to calculate the greatest common divisor, and this does it basically the same way. Its recursion thing's a little bit different, but it's basically the same thing that we wrote, and it might just be that it supports negative numbers better than I did. Okay, so that's cool. I didn't know that. To implement the least common multiple, you basically want to implement the greatest common divisor and then use the formula between them. Cool. I definitely didn't realize that. That's a fun trick. Nathaniel says coprime numbers are ones that don't have any common multiple but aren't necessarily prime. Think 3 and 10. Oh, okay. Yeah, thank you. That was helpful. I do... Like, no, I remember at least a little bit about like the coprime numbers, and that makes sense. That they don't share any multiples. Nice. Okay, cool. Thank you for that. That was definitely helpful. That helped get it into my head a little bit. Let's remove some of these debugs. Let's just clean up our answer. But I think, oops, debug. There we go. Just these ones. Yeah, perfect. Okay, cargo run. There we go. Printing out our answer in under 500 milliseconds. Love it. The least common multiple and least common multiple with the greatest common divisor trick. I always want to call it denominator, and I guess those are pretty the same. Denominator and divisor are pretty interchangeable in that context. Okay, well, I think we are gonna wrap up for the day, team, or at least for this puzzle. I think I'm gonna try to do another one this evening for day 9, for the actual day we're on. But for the middle of the day here, I think I'm going to get out of here. Thanks so much for coming and hanging out with me, everybody. And thank you so much, Opus and Nathaniel in chat for hanging out and guiding me. And thank you guys for giving me hints when I asked and not too many when I didn't. It was perfect. And so yeah, I'll get out of here for the middle of the day, team, but I will hopefully be back later today for day 9. I hope everyone has a great weekend, and I'll see everyone online in the meantime. Thanks, team. See ya.